have to make sure that for the 80 miles an hour, my ends are the distance.
There's no way of just having one line of code
that adds
that's like
both.
Yeah, like so not like calculation both, but like one.
All right, so hi guys, those of you here for Labview, welcome. Those of you that aren't, hi, thanks for coming anyways. So these computers do have Labview installed on them, so just go ahead and pull up Labview. It may or may not ask you for an activation. If it does, then raise your hand and Mark and I will come around and activate it for you guys. All right. So we're going to activate these two computers over real quick. Marco, just log in with your Labview stuff over here. Did you guys?
Yep.
Yeah. I mean, yeah, correct. I mean, I just made it user friendly. Like for example, if Dr. Ingram wants to go and check my code out, he can just put, like, oh, what engine displacement do you want? 4 liters or 60 miles an hour, and then it's gonna spit the velocity graph for 60 miles an hour, and it's gonna show the braking power for the liters that it shows. Oh no, because that's the.
All right, so yes, Nigel.
That's how the station works.
Okay, yes, Mark will come help you. All right. So for those of you that are now activated and have already logged in or are waiting for activation, please just pay attention and hold on, strap yourself in for the ride. It'll be fun, I promise. Yes, Heather.
You can hard code it and just put.
I don't know. I texted Taylor and he said that they were going to probably not be able to show up. That's why we're doing a live stream, because it can record for later. So I figured this out like literally 5 minutes before we started. So yeah, cool stuff.
The thing about an input.
All right, so does everybody have Labview open? Raise your hand if yes. Wow, you guys are slacking over there. Come on. I know. It's sloading. All right, so raise your hand if you have Labview experience. Okay, cool. We're gonna start from the beginning then and teach you guys from the basics. So, all right, we're gonna start. Just type in Labview. Make sure you're activated. It'll pop up. That's okay. And you'll be presented with, eventually, this very nice screen here, which should be right here. It's not showing up yet because it's still loading. I think.
Remember, if you guys don't know how to do something, just put help.
There we go. Okay. You'll see this. It's loading up. All sorts of fun things. All right. So it is up. Okay. So in Labview, for those of you guys that are following along and have this screen up, yes, raise your hand if yes. Cool. All right. So there's 2 ways that you can then start to make a file in Labview or bring them into Labview. You can either just make a standalone application, or you can create a project. So I'm going to show you how to do both of those real fast. So you go over here to File, and you can just make just any new program just by hitting New VI, and you'll get your front panel and your block diagram. So that's pretty easy. You know, if you want to just do some standalone test, or you want to just write some quick code, that's how you would do this. Or what you can do is you can go to File, New, and under here under Project, you can open this up and click on Empty Project. And what this will then do is, if you have something more complex than just one standalone program, you can have it so that everything is interconnected and they're talking to each other and they're all in one spot, so you don't need to dig around in your file explorer to try and find your files. So makes things a little bit more convenient and easy to take hold of. So what we're doing today is we're going to be working out of a project file here. So everyone pull one up and make sure you got this on your screen. Raise your hands once you got it. Actually, raise your hand if you have a question about this. Yes, Heather. Oh, Marco?
I got it.
Nigel?
How do I say control to get that view? Is that on the front panel or on the block diagram?
So close the front panel and block diagram so you can see the Labview screen here, the opening Labview splash screen.
So
and then you go to File, New. No, not a VI. Welcome, newcomers, Bradley and friend. Hi. You guys here for Labview?
Yeah.
Wonderful.
I'm gonna have to go now, but.
So, Bradley and friends, when you guys get logged in, it's going to ask you for a Labview activation. Just raise your hand when that pops up, and Marco will come around and help you with that.
All right. Yeah. Also, if she doesn't actually have an account,
No, it's okay. We'll be activating under our accounts.
on the computer. So,
Oh,
let me get a piece.
like a school account to log in?
Yeah.
Gotcha. Marco, you want to log in onto that one? Okay, cool. All right, so Marco's helping her get logged in, and then once you guys pull up Labview, it'll ask for activation, and Marco will help with that also.
So you might want to pop one of those doors.
Okay, so while that's getting done, you guys can watch and see what's going on, so you can kind of be like, okay, when you get popped up, you know what to do. So we're opening up a nice new project for those of you guys that just walked in. I'm going to show you again. Go to Labview. You're going to go to File, New, go to Project, and Empty Project. Double click on that, and you got a nice new empty project. As I was saying, this is really good for being able to have all your files in one place, so they're talking together nice and easy, and don't have to dig around and look for them. So we are going to then go to File, New VI, and it's going to pop up two screens. Those of you that were here earlier saw these earlier. I'm going to explain them now. So Labview has a built-in, it's called a front panel or a GUI. It has that built-in view, so you can kind of quickly and easily put stuff up to see on this side over here on the front panel, and on this back panel over here, the block diagram is where you actually put all of your code. So Marco and I kind of designed a couple of quick things, and we're going to show you how to start from the beginning. So to make code in Labview, it's a little bit different from regular programming because it's all done not by lines of code, but by logic flow. So what you're going to do is you're going to right-click on this block diagram over here, and it'll pull up your functions. This is how you add in stuff into Labview and make it do what you want to do. So we're going to start off by putting in just some numbers. So if you hover over the number palette here, it will show you can do math. You can add, subtract, multiply, divide, all sorts of other fun things that we'll get to later. And then down here you have two different constants. You have a numeric constant and you have a double constant. And there's two different ways of showing off what you're doing. Marco, you're going to want my power supply. That's going to die in like 5 minutes. Also a mouse. Okay. So what we're going to do is we're going to first drop just in a numeric constant because it's easiest to work with. And yeah. So as you can see, we now have a constant 0 in our back panel. Yes, Nick. Yeah. If it wasn't clear enough, you actually have to click after you hit that. So you can click on this and get a little hand function on top of your number, and you have to click to place it. Okay. So now we can make this number to whatever we want it to be. We can make it be 500, right? We can make it be 10,000. We can make it be whatever we want it to be. However, you can't use decimal places in this, I don't think. Oh, okay, you can. But as you can see, it turned orange. What that did was it took it from being just a numeric double or constant here and turned it into a double, which is the equivalent of a float in other programming languages. So it automatically changes it for you, which is one of the great things about Labview, is that it will automatically change your data types. You don't have to actually worry about that unless you're trying to specifically go to one. So as long as you're just using numbers, just don't worry about what type, because it'll just auto-convert for you. So, all right. So now we have two different types. One is just an integer, which is the blue one, and then one of them is orange, which is the float. You can tell it's a float because it has decimal places. Congratulations. Okay. So then we want to say, okay, I have these constants in my background, but I want to be able to see them over here on my front panel, where you actually see stuff when code is running. So what you do is when you hover over the right side of this, you'll see a little flashing thing and a little spool of wire pop up. If you left click, you now have a shadow line here that tells you where you're trying to connect to, and you can move it around and create all sorts of wiring issues if you have to go around a bunch of different stuff to get to where you have to go. If you want to cancel out of this, just press the escape button and it goes away. So that's how you wire one block to another block in Labview. So now let's say we want to see this. So instead of just wiring out into the middle of nowhere, what you're going to do is you're going to right-click on that, and you're going to create an indicator. And it says numeric, and over here you see popped up a indicator called numeric. So this is saying, okay, you did something on the back panel in the background of the code, and I want to show up over here on my front panel. So if I change this number over here to whatever else, you might notice it doesn't automatically update because the front panel didn't get run yet. It only updated the first time because that was the number already in it when it was made. So what you can then do is you can hit the run button up here where it says run, this little arrow, and we'll update that number to our new one. Now let's say we have a really big number in here, right? A bunch of digits long. So what that did was that actually broke it down because it was too big for it to hold. But then over here, if you say you have a really long number, you can stretch this out and it'll show more digits. So if you run it again, it'll update, and you can see we now filled up more of our space. So then we're going to right-click over here, and we're going to create an indicator for this guy also. And as you can see, part of his back end is cut off, so we're going to stretch it out so we can see more of his value. Now this automatically put it into scientific notation for us because Labview thinks that we're smart enough to understand this. So what we're going to do is we're going to right-click on the numeric. We're going to go to display format, and you can see it says automatic formatting. You can leave it like that, and then you can just increase the amount of digits that it has, and as you can see, it's showing more and more digits. And we can bring it down as it shows less and less and just does scientific, and bring it back up to give more digits of representation. Yes, I'll show that again. So you're going to right-click. Okay, so we're here, back panel. We made a icon, right? And we go over here to the front panel. We right-click on it. We go down to display format. And then under, it says display format, it's under automatic formatting. Just leave it like that. It's smart enough to do that. And you can increase and decrease your digits of precision. And you can see it changes from scientific notation to digits after it. And you can increase it so that when you have more digits afterwards, yeah, eventually it'll do that and show you the full digits, which is the imperfection in floating point numbers. Don't worry about that. You don't really need that for your day-to-day life. That's just floats trying to round in math and not being very smart about it. Because you can see it's not exactly 0.666, it's 0.66000002. So we want to hide that, so bring it back down just a little bit, and it'll hide itself. All right, so that's how you make basic numbers for just a constant on the back end and display it on the front end. But now let's say we want to be able to change stuff on the front end and affect the back end. We're going to do that. You're going to go over here to numeric. Just grab your number, right? Give it some constant, and then right-click on it and change it to a control. Ta-da! And now numeric 3 over here on the front panel is now a control. You can type this in when it's running over on this side, so you don't actually have to change constants in the background. So instead of hard coding a value over here, you can change it while the program is running on the front end. So if I go ahead and create an indicator from this guy, right, create indicator, you can see over here that numeric 4 is going to show what we're doing in runtime. So I'm going to change this to say some number, and I'm going to run the code, and it pops over on numeric 4. Everybody have that so far? Nod, shake your heads, wave around, I don't know. Thank you, Nigel.
So what's the point of creating the front line?
So when you're running your program, you're not going to see this back panel. You're going to see this front panel over here. So if you want to change a number on the fly while you're doing your program, you make it a control so that when you run it, it'll update your numbers. Whereas these guys, they're hard-coded in and you can't change them while you're running. But actually, we're going to do a quick thing because Labview thinks everybody wants to look at these big blocks, but they're big and in the way, and I don't like them. So you go to Tools, go to Options, This will give you a bunch of options so you can customize your lab view. What we want is we want to go to block diagram over here on the left, and then place front panel terminals as icons. Unclick that. So get rid of that guy. We don't want them checked. And press OK. Then we're going to delete these guys. So just left click, hold, drag until they're covered in the box. Then they're all kind of got this funky moving outline. And then just press delete or backspace, and it gets rid of them. So then we're going to go to numeric constant, drop it in, and create an indicator. As you can see now, it's a nice streamlined little block, which makes when you have large code much, much, much easier to handle because there's less clutter. So we're going to change this guy to control, and then make him be, I don't know, some number. Run it, and update numeric. All right, pretty easy, working with numbers front and back. Any questions about that?
You can adjust it on the front side.
Correct. Did you hit the run button afterwards?
I got it.
And then hit the white run button over in the top corner here. Hit the run button.
Right, it should change. It
Yes.
hasn't changed on the back.
What do you mean back here? Let me see what you're doing real fast.
Oh, okay. I thought you were talking about no. This is all the code part. This is your front part that you actually changed.
All right, so if you couldn't hear me when I was talking this now, Nick was saying he had a question about why it wasn't looking like it was updated over here in the back end, because you don't need to update it back here. This is just the code part. Over here is what you're actually seeing when you're running your program, is you see this front panel area. All right. We have another newcomer. Hi, Yates. Not Yates. I'm sorry, Yakubu. I called you Yates. All right. You have Labview on your computer, right? You have Labview on your computer?
Yeah.
Okay, you can use that because that way we don't have to waste time getting you plugged into these computers.
Oh,
All right. No, it's because you're both name starts with Y, A, and I always mix you two up. It's okay because I mix up Marco and Michael all the time,
Okay, that makes me feel better.
and I live with them. All right, so it's kind of boring, or not boring, but it's annoying to have to hit the run button every time you want to update your values, right? So what we're going to do is we're going to show you how to make this program run, well, until you tell it to stop. So you're going to right-click, go to Structures. You're going to get a while loop. And then you click, and you have this nice big box, and you click again, and now you have a loop. So right-click, Structures, while loop. This guy, right here in the middle. And you click, and you drag, and you click again. Or no, just click, move your mouse, and then click again. Don't actually drag, just click, move mouse, click. So now we have this big loop, and we want to run our program, right? Uh-oh, there's an error. So if Labview ever finds an error in your code, it won't let you run your program. It'll say, hey, here's an error. And then if you click Show Error, it'll highlight what the error is. So it highlighted our big while loop because it's saying, hey, there's something wrong with your while loop itself. So the issue is that this stop button down here does not have anything wired to it. So this while loop will just run forever and basically brick your computer because you can never kill the while loop. So what we have to do is you have to right-click on the left side of it where it's got the little flashy thing there, which says loop condition. You right-click and you create a control. And you can see over here, the stop button popped up. Hooray, you have a stop button. And to make it easier for you, if you hover over it, you can kind of see like the outline of it where it's got the blocks you can click and drag. And click and drag and make that stop button nice and big. That way you can hit that big stop button from wherever you are. Move my numbers around so I can move the stop button up here. Okay. So now this loop will run as fast as possible for as long as possible until you hit the stop button. So if you hit the run button, it's not running. As you can see, the little grid lines disappeared over here, meaning that it's currently in its running state. So if you change these numbers, they're being updated in as fast as it can possibly run. So this is say, hey, you want to just constantly update these numbers. Outside, there's updates because it's always running. And it's always checking, hey, check my control, put the control out to my value. And then when you're done running your loop, you just hit the big old stop button, and it stops everything. Any questions? No? Everybody makes a stop button and a loop, and it works, and it doesn't actually break itself?
Can you,
From what part?
so right after you launch, stop.
Okay, so I just made the stop button big just so I can click it easier, and I just hit the run button, and now our loop is running. And I can change my number, and it automatically updates as soon as I click outside of it. Right? This way you don't have to keep clicking run, because that's, boring. Let me come take a look. All right, so now I'm gonna hit the stop button. I'm gonna teach you guys a little trick. If you want to just quickly run your code, but you don't feel like trying to move your mouse around over to the big to the tiny little run button, you can hit Control R, and it'll run your code right away. It's a fun little shortcut that you can do. No, it does not. Control S saves. So you hit the stop button, and then you just hit Control, or hold down Control, and then hit R, and it will run. Any questions? No? Yes. All right, any other questions about making loops? No? Cool. All right, so Marco stole my computer, so I can't have my thing up to show you, but no, it's okay, Marco, you can stay back there. Yeah. Unless you're done with the hangman. Are you done with the hangman? Almost? Okay, keep working. Thank you. All right, so I already made a couple of programs, so I'm gonna try and pull them up and not look at them on the screen so you guys don't get the cheat. Give me a second. So I already built my own little project folder over here. I'll teach you some of the fun things about this. Actually, I'll teach you that now. All right, so we want to now save our program, right? Right. So you can either Control S or go File Save. File Save. And it pulls up, the save as. So we're going to go to desktop because that's the easiest place to view things on these computers at least. Make a new folder and name this folder whatever you want. I'm going to name it in class. Open my folder. Then I'm going to change my name over here. I'm going to call this coin flip because we're going to turn this into a coin flipping program. I recommend you guys call this a coin flip also. All right. So now you have a saved file. What we also want to do is you want to close your arrow list if that was still open. Close that. Go over to your untitled project, right? And as you can see here, CoinFlip has brought itself into your project because you opened up and you opened the VI from the project, and you saved it, and then automatically said, okay, I know where this one VI is. So we're gonna get to that next. So we're gonna go to File, and we're going to save the project. And so we're still in the desktop in-class folder, and we're gonna call this the in-class project library, or not library, in-class project, in-class project. Okay. You can see that's updated the name from it right here. Okay. So what we're actually going to do is I'm going to show you some of the advantages to this and some disadvantages that you have to be aware of. So if I close my coin flip and I close my in-class project, don't do it on yours. I'm showing you. So reopen that back up if you closed it. So if I open up my in-class over here and I take coin flip and I move him, to the desktop outside of my folder. And if I try and, oh, you can be closer now. If I try and then go to open my project again, it'll say warning, has been deleted, renamed, or moved on disk. So that's something you want to be aware of. If you move your VIs out of where it's expecting to look for, it's going to freak out and be like, hey, you got an issue. So the best way to do that is to A, not move it, or B, if you do move it, because you have to move it, what you can do is you can right-click on it, and you can go to find missing items. That didn't work. Go to replace with, and then navigate to where your new one is. You can click on it, and it'll update it and say, hey, this is my new guy. Or this is where it's been moved to. Yes?
If I copy and paste, it will do that? Or still do it as is?
If you copy and paste it, then no, it won't give an issue. It's only if you move the file itself. So what I'm going to do is I'm going to move CoinFlip back into his folder, and then going to close this. And I'm going to reopen it, and voila. The warning has disappeared because the CoinFlip has been back where it's supposed to be. All right. This project over here, this project over here. Okay. So what I have over here is, this is my project that I made, and I'm going to pull up my CoinFlip program to kind of show you. It's a very messy front diagram. But if I run it, I got with 3 issues because I didn't specify how many number of flips I wanted. So through not a number error. So what we're going to do is say, okay, make this run for 6 flips. And I know it's all messy, but you can see over here that my probability of hitting tails was 83% on this run out of 6 flips. So that was 5 numbers of tails, and 83% of my flips are tails. If I run it again, I got 2 tails, so 33%. And we're going to make this program now so you guys can generate probability and statistic numbers from coin flips. Run it again, 3, 0, 2, whatever. Increase this up to 100. Run it. 47% of my flips were tails. So we're going to make this guy. Yeah, don't save. All right, so open up your coin flip program again, if you closed it or not. And what's going to happen is it's going to open up to just your front panel, right? And then what you want to do is actually make this shorter. And what you can do to make this your life easier is to quickly access your back panel. You hold Control and hit E, and it pulls up your back panel. So that way you can quickly flip between front and back. If, say, they were over top of each other, if you Control E, quickly flips. Right? So this way you can go back and forth between front panel, back panel really easily if you're working on stuff. Yeah, so hold down Control and hit the E button. So Control E will flip what you're focused on. You can kind of see it's the focus flips, but yeah. All right. So one of the recommended coding practices in Labview is you only write your logic in one direction. What I mean is either write your logic left to right or write it top to bottom. Most people prefer left to right because then what you can do is you can just easily and quickly just scroll left to right and kind of read the logic flow as it goes on, which is helpful because if you make it to go up, down, and left to right, you got to search, pan, and zoom all around in your stuff, and it makes stuff for very, very messy code and hard to read, like the IGBC code we were given and had to deal with, and it's still so messy. So either go left to right or up to down. That's up to you. I prefer left to right just because it's easier to read. So what I'm going to do is I'm going to delete this stuff. So start blank, nice and fresh. And then what we're going to do is we need to generate a random number because we need coin flips, and for that we need random numbers. So what you're going to do, right-click, go down to numeric, and then go over here to our random number. This is a little dice block. So grab that and drop it into your code. And it's going to be a little dice block here. Right-click on the right side of it and create an indicator. Number 0 to 1. All right, so this will give us some decimal number between 0 and 1 when we hit run, right? So we got 0.8309 whatever. If I run it again, it'll give me a different number. All right. So this is how we create different random numbers. For those of you that seem confused, I'll show you again. Right-click, go to numeric, and in the numeric block areas, you can see down here it says random number. Drag this guy out and drop it over here. And then right-click on him, and create an indicator.
So an indicator is just one of the reports that was down there. Well, control allows you to control it up front.
Yes, for those of you that weren't paying attention or didn't hear, Nick asked the question of what's the difference between a control and an indicator. The control is the front panel control that you control. When the code is running, you can do whatever you want to that within reason of whatever the number is. And an indicator displays what happened. So if you do math, say 1 plus 1, you make an indicator, and that will show 2. Right? Good? No questions about that? Cool. All right. So now we have our random number between 0 and 1, and we want that to be not just 0 to 1, but 0 or 1 for heads and tails, because we only have two sides of a coin, right? So what we're going to do, we're going to right-click. We're going to go to numeric again, and then one of these little triangles down here in the middle is called round to nearest. And what that'll do is it'll round it to either 0 or 1, whatever it's closer to. So you can drag out and you got this block sitting in here. And to wire it up to this guy, if you bring your little cross pointer close to the wire, you'll see it turn into a spool. You're going to left click, and now you have spool coming out. And you're going to go, and when it connects itself to the back end, you're going to click on that, and it's not connected. All right, so I'll show you guys again. So get close to your line up here, click on it, and then you have your spool line, and then you're going to put it into the backside of the number, or the round to nearest number. Everybody got it? Raise your hand if you don't. Great, okay. So now we can then right-click on the round. We're going to create another indicator. And you can see now we have over here this nearest integer value guy. We're going to run our code and give it 0 because 0.421742 is closer to 0 than it is to 1. We run it again. It's still close to 0. Up, now it's closer to 1, so change to 1. Close to 1, close to 0, close to 0, close to 0, close to 0, close to 1. All right, so that is simulating 1 coin flip each time, right? Saying, hey, 0 is heads and 1 is tails, or whatever you want it to be. So now we want to say, okay, but what if I want to run this more than once and have it tell me the information about it? So for that, we're going to go to structures. We're going to go to for loop, and we're going to click over here, and we're going to click down here on the other side, and we have a big old for loop. You might have noticed that this is now broken, saying we can't run, which is true because we don't have this thing wired up properly. What we need to do now is we need to, on the left side of this n up in the corner, it's called the loop counter, right-click and create a control. You can see we now have a control numeric over here. And what we want to do is we want to rename this. So double-click on the name. It'll kind of highlight it. Double-click, it'll turn black. And we're going to call this number of flips. All right, so we can now say, okay, I want to flip this guy. Well, if I do 0 times, it's not going to do anything because it's not going to run this. But if we say, okay, we want to run it at least 10 flips. Uh-oh, we didn't get to see all the flips that happened. Well, that's because this is only giving us the last flip because this runs so very, very fast. What we need to do now, we need to somehow get this out of the for loop and display all of the flips that happened. So what we're going to do is we're going to click on this guy and get our spool. And we're going to go ahead and connect it to the side of the for loop. All right, so now that we have this, we can then right-click on the right side and create an indicator. And now we have over here, you see an array that popped up. It's called array. And if we say, okay, run our flips now, now the array has been populated. So for the 0 flip, we got nothing. On the first flip, we got heads, tails, heads, tails, tails, heads, tails, tails, heads. Uh-oh. Why is 10 empty? Well, Labview starts its indexing at 0. So the 0th flip was actually the first flip. So 0 to 9 is the same as saying 1 to 10, because it's a 0 indexing programming language. So, okay, I can see them one at a time, but what if I want to see my entire array? If you hover over the array, you will see these blue boxes come up around the outside of just the array. And what you can do is you can then click on the bottom one and drag it down. And voila, you can now see your entire array. These ones here are darker and shaded, saying, hey, we're filled up with numbers. These are not, because there is no data for the array past that. So if we hit run, you can see that some of the numbers are changing, because different flips gives you different probabilities. Right? Now, if we increase the number of flips up to 14 flips, you'll see that, oh, look, now more of the array got filled out because now there's more data to fill. So, okay, so we now have a flip counter that can count the number of flips we have based on what our input is and give us an array of values. Now we need to decide, do we want to make 0 be heads or 0 be tails? Raise your hand for 0 for tails. 1, 2, 3, 4. Okay, raise your hand for 0 for heads. 1, 2. Okay, 0 is tails. So to remember this for us, you're just going to double left click anywhere in your back block diagram over here, and you can type in a note. So we're going to say, okay, 0 is tails. I can't spell. So this is our code commenting. You can just double left click anywhere you want and type in whatever you want. And this is your comments. It won't show up on the front panel, but for you, if you have large programs, you can say, okay, this is why I did this choice. This is what this value is. This is why all this math happens here. So it makes it so that your life is sane when you're trying to read your code later after you've saved and closed and went for a lunch break. Alrighty. You just double click anywhere. Yep. Pops this little box, and then you type in whatever you want. And so if you double click, you don't type anything and then click somewhere else, it'll go away because there's nothing to display, so it just goes away. All right. So now what we need to do is we need to do math on our array. What we want to do is we want to find out how many of these are equal to 0. So what we're going to do is go inside of our loop. We're going to go to numeric. No, we're actually going to go down to comparison. And one of these blocks here is equal to 0. So we're going to drag this guy in and drop him on in. So we're then going to wire him up to our value here. This is our flip output. Right? So now we can say, okay, is it equal to 0 or not? And it's a Boolean, true or false. What I'm going to do is I'm going to increase the size of my while loop so we have more space. And then we're going to go up here to structures. We're going to go to case structure. And then we're going to build a case structure here. And this is your if. Right click. Right click, structures, case structure, and then make yourself a nice true false statement case here. We're then going to wire up our true or false to the little selector over here. And so this controls is saying, okay, if this is equal to 0, it's true. If it's not equal to 0, then it's false. So if it's equal to 0, we want to count how many we have of tails. So what we're going to do we're going to go to numeric. We're going to go to increment, and we're going to drop it in here. So what this is going to do is that every time that it says it's true, we're going to increment some number up 1. Now to do that, we need to have some initial number. So what you're going to do is you're going to attach this to both sides of your while loop. Get on the wall. On the wall. Okay, well, you see I just messed up here. I don't know why, but yes, increment. So if you have a broken wire, you can try and go ahead and delete each of these by itself, but that takes a long time, and you might actually get a spool in here. It's very annoying. So what you can do is you can hold down Control and hit B, and it gets rid of all your broken lines. So what I'm going to do is I'm going to try and reconnect that over here to this guy. Come on, connect. Okay. So it's still broken, only because there's no input. What I'm going to do is I'm going to go to numeric. I'm going to grab myself a double and drop it over here and connect it to that broken value. And it makes the line nice and clean. Under numeric, right-click numeric. That's the orange double. All right. So this is going to say, okay, our count starts at 0 before our loop starts. And then every time we hit 0, we're going to add +1 to it, right? So however, how do we get this number to go back to this number so it can actually add the numbers together inside of itself? What you're going to do is you're going to go over to this guy. It's called the tunnel. Right-click on it, and we're going to replace with shift register. So now your mouse turned into a copy of this, and we're going to go click on the input terminal. And what this does is say, okay, every time my loop starts, I get in 0 initially. It's going to go 0, 0, 0, 0, 0, up. Got true, so +1. And it's going to take that number and send it back to the front when the loop restarts. So now, however, we are still broken. Why is that? Well, it's because we don't have anything wired up to our false case when the number is not 0. So we still want this number to come through, so we're just going to click on this guy and connect it to his terminal over there, and now we're nice and ready to run. So now we're going to go over here to our end of our shift terminal, right-click, and create an indicator, number of tails. I can't tell. Okay. Now when you run this, this should tell us how many of these numbers in here are going to be 0. So we're going to hit run. We have 8 tails. Did everybody get that? Did I lose anybody? Yes. Okay. So okay, back to sharing the screen. Just wanted to make sure that you were still screen sharing. We are. Okay. We might have lost that for a little bit. I'll have to look at this later. But okay, we're sharing again. Okay, so what we're going to make now is we are going to make the... Okay, we're going to work on some strings now. So words. So, again, File, New VI when you're in your project. I'm just dragging these to the 2 sides of the screen so I can see both of them at the same time. So right-click and go to String area, and grab a string constant and drop it in. And we're going to type in a string, hello world. Bookend type, or spell, and create indicator, hello world. Create. There we go. Nope. What I did was I went to string, and grabbed a string constant, and dropped that in. Gotcha. This is the computer. Then we hit run, and it'll update our indicator. But uh-oh, it blocked off part of it, so we gotta drag it out. All right. So Labview has a lot of built-in functions that are really easy and fun to use about strings. You can go to path and array. No. You want to revert your string, you go to right-click, you go to string. All the way down in the corner says additional string functions, and this little one is reverse string. Drag it in, drop it up, connect your wires, and just get reversed, and then you can type in whatever you want, and it'll be reversed. Let's change this guy to a control so I can type in easier. So, okay, what if you're looking for, say, a palindrome? Say, I think the easiest one to think of is Taco Cat. Taco Cat.
After you make the reverse,
Yep, so drop in the reverse function and just make an indicator, just so you can see what the reverse string is. Right. Taco Cat is Taco Cat forward and backwards. One of the easiest palindromes there is. What you can then do is you can right-click, you can go to your Boolean, not your Boolean, your comparison again, and say, hey, are these two strings equal? So we're going to wire up string number 1, we'll wire up our reverse string, and notice that this changed it into a string type, and there's no little red dot because it changed the type of this automatically to a string comparison. And right-click and create an indicator. So if are the strings equal, you run the code, ta-da, it turns on, your strings are equal. If I change it to something that's not a palindrome, Taco Cats, nope. Taco Cat is not equal to Taco Cats. Not equal, yeah. So this is easy. You can then get rid of your strings, just delete them, and hit Control-B to get rid of your broken lines, and drop in, say, two numbers, say numeric number 1 over here, and then create another constant over here. Actually, no, controls. So is 500 or 5,000 equal to 500? No, they are not equal. 1,000 is only equal to 5,000. Now they're equal. All right, so you can make this be whatever data type you want, and you can compare them and say, okay, is this value equal to that value? Yes.
I am lost.
Sorry, guys. If I was going too fast, someone said I was going too fast. I'll show you again. Go to numeric constant, drop it in. Yeah, no, just get rid of your strings now. I'll show you how to do it on numeric side. So right-click on your numeric, change it to a control, drop in another one, change it to a control, numeric 1 and 2, go down to your comparison, drag in the is it equal, wire them both up, and make an indicator.
So make two constants to make it equal.
Yep, two constants or two controls, whatever you want. Put them into the comparison equal block, and then create an indicator, which is a Boolean true or false, and then run it, and you see yes, 0 is actually equal to 0. Surprising and shocking, I know. 500 does not equal 0.
Does an X equals Y question mark? I just say.
Oh, okay. So go to tools.
Yeah.
Go to block diagram. So the icon is just a block and you just okay. Just make it less better. The same thing. Oh, just control. Yeah, so be careful. You cannot wire an output to a control. So if you right-clicked on this and accidentally made it a control, it won't wire up and it'll give you a bad wire. Make sure that this is change it to an indicator. You can actually indicate stuff. All right, because 500, what a 500? That's your indicator. Oh, yours is a different type.
Oh, wait, for the overall color? Yeah.
Okay. So you can now compare numbers, you can compare strings. It doesn't matter what data type is. You can compare them as long as they're the same. All right. So our next little program that we're going to make is we're going to make an alarm clock. So you can guys make yourself an alarm clock and say, hey, do something if the time is equal to that time. So what you're going to do is you're going to right click. We'll go to this timing block here. And you have a couple options. You have tick count, you have waiting. But we want this one in here. We want the get date time string. So you're going to drop it in. And this bottom one is the time. So you're going to right click, create an indicator, time string. So if you run this, it'll give you what the time was. Right click, go to timing, and the get date time string. Yep, so this will give you your time. If you got the top one, that'll give you your date. But we don't care about what the date is, unless I don't know you do. So date and time. You're at a date. Wonderful. All right, so make sure under timing you're getting this first block here where it says the get date time string. This one right underneath the tick count. Make sure you're getting that block. You get the other blocks that will give you different outputs, and we don't really want those. Make sure it's the get date time string. Now let's say you're online, you're searching for some block, and National Instruments says, hey, there's this cool block you can use to do something, but you don't know where it's hiding. If you go over to the search function, you can search for anything here. So you can search for the get date / time string, and you can drag it out from here. So let's say I want to get wait block. Hold on, wrong. Wait block. This is if you don't know where a block is hiding, you can type in the name under your search. All right. So now we have our time, but we can only run it once, right? And then it stops. You want to make this run forever, so go ahead and grab yourself a while loop and enclose your time string inside of a while loop. Make yourself create a control to make a stop button. Make it a little big if you want, and then run it. Now this will constantly be updating your time, and it'll tell you what the time is. In 30 seconds, it will change over to 3:15. Right? Any questions about that? So what we're doing is we're just constantly updating what our time is. So go ahead and hit the stop button. So now this is saying, hey, we're running this as fast as the computer possibly can run this code. I want to slow this code down. so that we're not checking for our time every possible time. What we're going to do is we're going to go back to timing, go to your wait block and drag it in, and then create a constant and call it 500. So this wait block is in milliseconds, so we're telling this loop to wait 500 milliseconds in between each run. So that way, instead of the computer how fast it can process it, telling it how fast to run, we're telling it how fast to run. So we can make it wait for half a second at 5,000 milliseconds. 1,000 milliseconds is 1 second, so we can check every second for an update. You can make it check, I don't know, however long that is, it'll wait between loops to check. You can have it wait for no milliseconds, where it'll just run as fast as possible. You can check every 5 milliseconds. But because we're just checking for time, we'll just check it every half a second. 500 milliseconds. Now, what we want to do is we want to now build our alarm setter. So I want to set my alarm for some time, and we need to figure out how to do that. So we're going to go here to numeric and drop in some numbers. Change it to control. Drop in another number. Change it to a control. And we're going to rename this one our hour. Name this one our minute. All right. Is everybody here? Yep. So create a control. Change your constants to controls. So now we have our hour and our minute over here on our front panel. So we can set what time we want. All right. So go over here to string and go down over here to its format into string. Everybody see where that is? Format into string. We're going to drop this guy in. And what this does is this changes a number to a string. So we're going to wire our hour up into here. And now it'll change from a number to a string. If I go make an indicator over here, some resulting string number over here, and if we run our code, we get 0 because hour is 0. But if I start increasing this, you know, right? So we're going to stop that for now. As you saw, there was a little bit of lag on this system when I was doing this. I went too fast, right? That's because there's a delay in there, so it's not running as fast as possible. That's what the delay does. So now what we want to do is we want to we want to have our minute be converted to a string. And instead of having to go through all of your palettes to dig around and find it, what you can do to quickly copy it is hold down the control button, click and drag on your block, and it makes a copy. Everybody get that? So hold down the control button, and then click and drag on your block, and it'll make a copy right there for you, and you can place it wherever you want. And wire up your minute. All right, everybody here? I'm not seeing any hands, so yes, I'm going to assume everybody's here. Yes, Jacobo. So in my string blocks, in here kind of in the middle, it's format into string. That's where I got it from originally. All right, so now we have our two strings, which is our hour string and our minute string. I can't tell. All right, so now what we want to do is we want to be able to compare these to our time string. So to do that, we're going to make them into one string. So go to string, go to concatenate strings, and drop it in. Wire up the top one to the hour, and the bottom one to the minute. and then go back to your comparison, grab your equal, and output this to here, and this one into there, and then create an indicator saying, hey, if they're the same, what up? Right, so go to string. The second one here, it's concatenate strings. And what it does is it just combines the two strings together. Drag that in, wire them up, put them into an equal block, and then make an indicator. Okay, so let's go ahead and run this. Let's set our alarm to 3:20 right now. Uh-oh. Why is it not saying they're equal? Well, pretty simple. Because we didn't give it any formatting to tell it, hey, this is hours, minutes, and time. Instead, it's just saying it's just 3:20, because if you create an indicator and run the code, you see it's just 3:20. And 3:20 is not equal to 3:20 p.m. So what we need to do is we need to format our string by adding in some extra stuff. So I'm going to delete this line here, and then I'm going to Control B and get rid of that. And if you hover over this block, you can see you can drag it down a little bit. Just drag it down, and voila. You can now add a whole bunch of stuff into your string beyond just one or two. So what we need to do is we need to add a little dot dot in between the hour and the minute. So when your second slot, right click on that, create an indicator. Nope, not an indicator. We want to create a control. Create a control. Still wrong. Constant. My bad. All right, and then just give it the little semicolon. And then we need to wire back in. The second one is back into our minute. Right. And we do have all this extra stuff. We don't need all these. We're just going to bring this back down. All right. So what we also need to do is we also need to have an AM PM selector, right? So what we're going to do, go to structures, grab the case structure, and put it down here. Inside of here, go to string, make a constant, and this is important. Make sure it's space AM, and on this side, make sure it's space PM. Space PM, because as you can see over here in our time string, there's a space between the numbers and the letters.
So what kind of structure is that? That's
Just a case structure. The structure is case structure. Yeah. And then wire up your constants to the side. Make sure they're both inside of the same little selector here. And then we need to have some way to control this. Say, hey, we want AM or PM. So we could make that just a true false, but we want to be a little more specific because someone might not know what true and false is related to. So right click, go to numeric, and get an enum constant. Drop them in here and wire them up.
where is Iman?
Numeric,
Okay, got it.
enum constant. Change this to a control, so right click, change to control, and you have an enum pop up over here on your front panel. Go over here to your front panel now, double click on the name, change it to AM/PM. Now we need to actually fill in the data slots because it's empty right now. So right click on it, go down to edit items, and you get this here. This is we're editing the properties of our enum. Is everybody here? Okay, I'll show you again. Right click, numeric, enum constant. Right click on the enum constant, change it to a control. Right, and then you have it down here. Rename it to AM/PM. And then on the front panel, right click, go to edit items. All right, is everybody here now? Raise your hand if you're not here. So I see some confused faces.
So you have like a little constant, right?
it'll tell you like how many you set up. So down here, which is the double thing right here. Yeah, so that's where you want to plug your number in. So you don't want to plug an error in. You don't have to plug it to that exact spot. Plug it where your number is supposed to go. Yep. That's the thing you care about. Plug that right. Yep. You have to go in there. So get rid of that.
Okay, so I have
Do the same thing.
and then I go on the side.
Now, I'll go for this again. So on here, you want the resulting string. So find the right side where you have the resulting string. Or you can right click on it, generate. And create. Yep. And that's where you want to do the control concept. You didn't hit control. So you just moved it. Sometimes the auto does.
All right, so now that we're all here on the enum properties, we're going to add our AM PM selector. Right? Is everybody here on this page? I think I helped everybody get to this page so far. Marco's helping everyone that's not? Okay. So click on the first items, double click, and it'll give you something to type in. So type in the words AM, hit enter, then type in PM. Then click OK. And now you can see that we have our selector. Now we'll have an AM and a PM selection in here, right? And on the back end, our case selector now says PM and AM. But it got them backwards. So it says AM here, but we have PM in here. So I'm just going to right click on mine, and I'm going to make this case PM. So if your cases don't line up properly, you can right click and go to make this case the other case right here. It's not at the bottom. Right, make this case only if your numbers don't line up. So my PM case up here is my PM output down here. Yeah, does that make sense?
Click on the, right click on this. So it'll go to edit items. So here now you can make the entire list of what items you want and have an exact value to them. So now you can say that put there, but you want this one more down.
Yes. It's
There you go. You can type AM.
All right, so.
Now you can type PM. Now you can get those. Go to your third one. Delete that. Now you have two values. So now you're doing a case structure on it. Or like case structure for it. Look at the structures. Case structure later. It's not run. It's like I didn't mean to run my first set. Here, just put it over. Yeah, like a just drag that over on this side. You know what I mean? Case selector, but you know.
All right, raise your hand if you're not here.
Yes.
Now, if you make this bigger, now what did you go? What's the actual value that you know? So if you know is that, is that so like this? So now So make a copy of this, drag it in here, so it is not that one, of the semicolon. You got control drag inside the case, and to change that to PM. So double click on it, so you can type in it. So you can PM. Alright, then plug it off into this box. No, keep it in there. Wait till you find the school on the side. Sometimes when I highlight, you can see it. Click somewhere else. Alright, so on the side. Yep, just with the bottom section. Yep. Now, go to the AND case, which is generating. Yep. Then go to AND. And do the same thing, make it really constant. Right now, just then plug it into the CX file. Sure, it'll show up like this black person or like that. Yep. And now plug that into this little dot thing. So you see that? That's the output. Now you see this little pink thing? That's your output for your other case. Plug that into that output. So now, and which case you get a different string coming out. So and you can string create create an indicator. One right click on this and the constant. So you have a want to get rid of like wires. You can also take control B and delete every single row of wires. There you go. Plug in this one. So just make it 500 milliseconds. No, it already automatically milliseconds. This gives you a while loop. So right click on this folder. Sometimes we get the while loop and we have some options to change it in the place for the while loop. And then right click and control. So control. Alright. So your code's gonna run. So now if it runs something, let's see what it looks like. So here's the code looks like. It's 0 hours, 0 minutes, and change that you change the minutes. Yep. Yep. So now that's what it looks like.
It's a lot of, you gotta know what things are. And
yeah, that's the other thing with Labview. Some people just type it, like, oh, I can search, oh, just type this. All right, cool. But Labview is a lot more finding. And sometimes it helps because it's like when you're not writing code, it'd be like a search bar where you can type into. But sometimes it's still kind of hard. So memorizing over time or just Googling and they tell you, yeah, then you're like, all right, cool, let's take it.
yeah,
Halfway, 4.5 years of life experience now. But when I got here, I didn't even know almost. So it takes a while to pick it up.
like
Yeah.
don't tell that. Okay, so, but it's like a video program.
Yeah. It can get incredibly complex or it can get incredibly simple. But the best part about Labview is it does like the parallel processing for you. Like you don't have to thread. All your things literally have just another file that's right next to that. Like do two things at the same time.
Yeah.
The only thing you have to be careful for, and that's what causes the delay things, is that we don't put delay in like any threading or try to run as fast as possible. So say you're just simply like several of those. Kick up your CPU. Like I had 60% CPU the other day because I didn't have delay, so I forgot. Oh god. And after like even a millisecond, and it was like back around 5%. So So it tries to run its hardest, but sometimes you only want to run as fast as you can. Yeah. But it handles parallel stuff too. Right, and it has a built-in UIs. So you can always see which one. Also, one from the Labview is running code. You want to know what something at a specific time is doing or not doing, or click on it. You see the little like movie thing, and we turn to a probe. And then you see, hey, here's the data have timestamp. So if this server is never updating, it's either you're waiting or you're not in that section of the loop. It's not executed, it's not got to that point when you click the probe button. So it helps you see, well, where am I getting stuck in my code? Is this number of blocks right? I didn't mess up there. Yeah, so a lot of things are functioning at the same time, so it's going to be the same loop. Sometimes you have like settings and that'll function and something else afterwards, but it also will take a little more time. Just like we do.
All right, so everybody should be about here now? Yes? Great, okay. So one of the things that we did notice was an issue with was that if you had your minutes being less than 10, say 2, it drops off the last part of that, which is not what we want, right? So what we have to do is on our minutes string over here, on our formatter, you're going to right-click on it, and then going to go down to Edit Format String. And then over here it says %D. And between the percentage and the D, we're going to put 2 and then a period. That's okay. And you'll see a little string builder that goes into the top. So what that does is if there's only one number, it'll make sure that there's at least 2 spots. So if there's not a 0 in front, it'll put it in front. If there's not one at the end, it'll put it at the end. So if we're going to run our code, it did that, which technically is still wrong. So right-click on the formatter, this little guy, go to Edit Format String, and it'll pop this up. So then we want to do is we want to change this to a float. So change that D for an F. So it's %2, period, and an F.
Now, what's the difference between the float and the D?
So an F is a float and a D is a double. What this will do is will allow us to have that 0 in the middle, as it should. Now. Yes. So, however, I think the same issue happens on my code that I made last night and didn't test because I never had that. Yeah, it does. Okay. Congratulations, we found a bug. So what we have to do is we have to right-click on minute. Give me a second. Let me check this out real fast. Display format. No.
I trailing 0?
I already have that. All right, it just does that. Well, it looks like we found a bug that I didn't encounter last night when I was making these. So congratulations, we broke our code. Don't set an alarm for anything that's not below 10. So we're going to make this be 39. Because it's 3:39. No, because that'll get rid of the 0. Okay. All right. So we now have our time string and our concatenated string, just PM. Ta-da! They're now equal. Right? 3:40 p.m. is equal to 3:40 p.m. for my alarm. So now we can take this and make this play a noise, vibrate. If you're not getting them the same, make sure you have spaces in your string constants for your AM and PM. All right, so this is space PM, and it is space AM. Make sure you have that space there. It's important. All right, so if you guys set your time to 3:41, do you guys get the true when they're equal? Yeah? I have one yes.
No.
No for you. Let's figure out why.
You guys sit there. Oh, I don't have.
All right, everybody's on track now? Your alarm will let you know that your time has reached its time. Yeah? Congratulations, you made an alarm clock. Now you have to add bells and whistles. So that's being like, okay, you want a snooze button, or do you guys want to add some noisemaker? Your choice.
Noisemaker.
Noise? I'm not getting any input here, guys. Raise your hand for noise. Okay. All right. Go down here to graphics and sound. We can make it either beep, or we can make it do some sort of sound output. So we're going to just grab beep for now. Duration, constant, make it last for 1 second. Frequency, make it constant, I don't know, 500 hertz. No, wait. Let's put 500. So wire it up so that true is your sound inside of your little case here. And if I turn up my music, yeah, so my duration is 1 second, so it's 1,000 milliseconds, and the frequency is 500, just because that's what I chose, and I'm gonna see if it does anything. Let's see if it actually does something when it hits the right time. Anybody hear anything?
Well, you shouldn't hear anything, right? Because it's not connected. It is connected. You just can't see the wire because it's that little light green.
Yeah, that's not me. I think it's somebody else. I don't know. Mine's not working. Somebody got theirs to work. Who got theirs to work?
I need to get the NLG around as the overall setup. Now what if I do style? Oh, I've got the sound on my computer. Yeah. What's yours?
Okay, 1 second. Okay, yes, my sound is just too low. All right.
Where's my sound? You're not. Oh, that's why. Oh, yeah, so we did it. So should I? Maybe. So the duration and frequency, the duration and frequency actually because it defaults to true, which has a preset. The frequency and duration is what false. So that's what it sounds like. If you listen to edit yeah.
Yeah, so Bradley was saying, for those of you that didn't hear him, if you make this constant over here false, right? If you put in a false into here, then you can actually make this do stuff. Otherwise, it's true, it's using just the beep noise. But if you make this a false, you can change your frequency. Change that to a control.
Make it super high. There we go. Oh, like a sign. Oh, you move right through it. Are you talking on your phone? You made that false. You actually use the frequency put there rather than control.
So yeah, so you made an alarm clock. Congratulations. You can now annoy all your friends by making it beep whenever you want.
So you can use this frequency stuff. If you had proof, it's using the system beat. So that sounds like annoying.
What?
I can make it annoying.
So what I did was I changed my frequency to a control. All right, so I can change my frequency on demand. Exactly.
Yes, please. Keep going. Baby the sound. Wow.
Oh, it's not mine. Oh.
So, for those of you who've been to Dr. Butka's office, that sound might be familiar because he actually has that on all the time. That super high pitch. He can't hear it. He says it's not never he can't hear it, but it keeps
Actually, an alarm
people from
sound.
sticking around for too long.
Yep, so changing your frequency will change how annoying the pitch is.
What's the frequency for a fire alarm?
No.
It's time to stop.
Mine's like the same, so like mine just keeps hearing the same. I didn't hear the word. You know, look. So that same sound that you. Oh, yeah, there's some strange thing where you got this whole symbol for the third No, not this thing, not the car.
Yeah, you can type it in as that user. See what was
Sorry, is there any updates?
Wake me up.
Can't wake up.
Save me.
You help people?
Alright, I sure can try. If it's about noises, I can show you how to shut it off.
Alright, so they can adjust the frequency.
Right.
Change the sound.
Yeah.
However, I try doing that.
Uh-huh.
I just get that same sound.
Yeah. How is it changing? Okay.
So I already
Oh.
make it annoying.
Oh. You know, I like characters. See what happens. Oh, that sounds good.
All right, so now you all know how to annoy all your neighbors whenever you want. Just make this program and just have it beep at somebody. All right, so don't forget to save it.
Oh.
Control S, save it, and then make sure that it shows up in your in here.
You have this, you plug it in. it'll use the default. You plug in a constant default, so it'll use whatever noise on the cat. Yeah, so you have control over my future and also your short future.
Now, if you guys want to get really annoying, what you can do is hook up a random number generator to it and have it make a different pitch frequency every time. No, I'm not grading you on this. So make sure you save it. Make sure it shows up in your class project, Labview Project Explorer thing, and then close it. So I can stop. So you guys can stop annoying me with all your beeping. Okay. All right. Take them. All right. So, we have a choice now. I'm gonna have you guys make this choice. Do you guys want to make a game of Hangman with Marco? It'll take you a while. We're gonna run much over our 4 o'clock proposed end date.
I don't have all day.
I do. You do.
All right.
Or we can try and make a quick change return program so that calculates, hey, I'm paying so much money to this guy, he's going to give me back change in quarters, dimes, and nickels.
That one's easier.
Yeah, but the easy route is always.
I don't want to be here for 3 hours.
I say easier, but it's still kind of complex because it uses numbers, strings, loops, and case structures. Hangman, though, is way off the charts crazy with that Marco made. But it works. It's really cool. Change? Okay.
You guys want to make them watch everything that works? Come forward.
Yeah.
All right.
Well, Marco's going to show us the Hangman game real fast.
Oh, also, for you guys who want to learn more about Labview, there's a YouTube channel. He can't. He doesn't. He never will. Nope. His name is Six Clear on YouTube. He makes brilliant, simple to the point Labview videos. You have like a project for like say 10 videos in a row, and it'll teach you the thing you need to know, like how to make a state machine, how to deal with strings, how to write to a file, how to do all this fun stuff. It's really brilliant, very simple, easy to listen to. He sounds sort of monotone, but a really fun.
Hey, Marco?
Hard to explain.
You can bring us a flash drive, you know. The
I
battery's going to die in like less than 5 minutes.
Yeah, I know. I walked. Save that. Check it out.
Thank you.
But yeah, if you guys want to learn a lot more or like get a lot of cool tricks, that YouTube channel will show you a lot of cool things.
Is there like a student version of Labview that's free?
I don't know. Marco?
Student version of Labview, sure there is, but who needs a student version when the school has a volume license, which gives you everything forever? Yeah, you can. Oh, we have this. Riddle has an actual license that people can use. So we just give you that, and you literally just make an account. You use that license key because it's a legal thing that Riddle bought, and now you have free Labview. Not just Labview, almost all of that.
Yeah, like all
modules, add-ons, cool things.
all the good stuff. All right, so
Hope you saved it.
I did.
Okay, cool.
Labview class.
No.
Yeah, this one.
Nope.
Where are we working out of then? I saved some things. Where are we working out of?
No. Oh, it's on the desktop.
Oh. Well, oh well. Marco can go plug this back in and turn it back on and try and recopy it over. Nice try. All right. So, while Marco does that, because he didn't tell me where it was saved, we're going to go File, make a new VI. Right there. Right there. Okay. All right, so go ahead and open up yourselves a nice new VI and call it Change Machine. Because that's what it is. Change machine. Okay, so in change machine, we're going to have 3 scenarios. We're going to start by making our first big case block over here. Actually, no. Start off with a while loop.
What's your password?
That's my fingerprint. Hold on. All right, so make your while loop, and then go down here and make sure you right-click and create a control. So you have your stop button again. That one should be here. And then go to structures, make a case structure. Make it pretty big. And what we're going to do is this is our true statement. Right-click, string constant, and just type in you've paid in full, or something similar to this. All right, so this is the scenario of, hey, look, you did something really good and you paid all your money. You're free to go. All right, wire it over here and create an indicator. All right, is everybody here? Yep. So you got a big while loop, right-click, structures, while loop. And then you go right-click, structures, case structure. And then you go over here to your string, grab a constant, and drop it in. Click and make your little spool guy here with your little ghost wire. Bring it over to the edge, and right-click, create an indicator. Everybody good? String, wire to the side, out to a thing that I renamed cashier says, and I dragged over so it'd be nice and long. Everybody should be here now. All right, so now we have the structure of you're paid up in full. Now go click on this and go to false. Right click on the empty block here. Actually, no, don't do that. Don't do that. Over here, click, and we're going to need some numeric. We're going to need a constant. Drop it in. Right click, change it to a control. This is cost of items. And then control drag it so you copy it. Call this one cash paid. Right, so now you have over here, you have your cost of items and your cash paid. Right. So now we're going to compare these two. So go to your comparison and say, are they equal? So wire them up. Say, okay, if they're both equal, then you've paid in full, right? So I'll show you what this is. So look, ta-da! You guys can't run this because yours is broken still, but I did mine something special. So you paid in full. If not, then you get nothing. So don't worry about that. I'm just showing you that how you can change that string. So now we got to go in here and say, okay, so if they're not equal, we need to figure out why they're not equal. So we're going to drop this guy in here, bring him over, and then bring him over too. So they're like this. So that what this means is there are now inputs inside of our loop here, and I'm going to straighten out the wires. Right? And say, okay, let's compare them again. Is it greater than or less than each other? So go to comparison. Is it greater? And wire them up again. Greater. So is the cost of items greater than your cash paid? And then you're going to go to structures and make another case structure here. Drop in a string and wire it up. And you're going to say, okay, my cost is higher, so you haven't paid enough. Make sure to wire up your selector. Mark again, make sure everybody's wired up properly. Thank you. Does everybody have this now? All right, so he's almost there then. Okay, so then go to false. Say, okay, since your cash paid is greater than your cost of items, string constant, your change is all right. So those are our three cases. Either you're paid in full, you haven't paid enough, or your change is something. You're going to run it, right, and say, okay, the cost is too much. You haven't paid enough yet. You paid too much. Your change is something.
Everything good?
Yeah. You got streaming too. So now we need to actually find out what our change is. That's where it gets tricky. Go to numeric, this guy here. Go to quotient and remainder. Drop them in. Bring in these wires. And what you're going to do is go to math again. You're going to subtract your cash paid minus the cost of items. So we have them flipped. Yeah, that's a minus. So numeric, subtract. And you're going to flip the wires so that your cash paid is then minus cost of items. And this will give you some XY value that is your cash paid. So you get rid of that, you can say, okay, your change would be $1, or your cash paid would be, whoops. All right, so I've actually found out that there's an issue with this. Does anybody see it?
No actual change.
Exactly. You don't have any actual change. It's all just numbers, straight up integers, right? So I can't make this be 1.50 is what you owe. So it just goes to 2. So what you have to do is right-click on your cost of items, go down to representation, and click on double precision. And that makes it orange, which is basically a float, double. And then go to cash paid, representation, double. Makes it orange. And then you can delete this guy and remake it, and it will be the proper size. Proper color. All right, so now I can say, okay, cash paid is $2.50. Clear change is $1.50. That way we can actually have decimal places and say cash and change.
So right click the control, get down to representation.
So right click on this guy, representation, and make sure it says double precision. Everybody there? Yep, double precision. All right, so now this is this XY value, X minus Y, is our number that we're going to want to turn into change. So we say, okay, I have $1.50 change, and I need to break that down into dimes, quarters, nickels, and dollars. So we're going to start out by going to our numeric, grabbing that quotient and remainder block that I deleted earlier. You're going to take this guy, and you're going to divide it by 0.25. So make it a constant, 0.25. All right, so what this is doing is taking your change and dividing it by quarters, and finding out how many quarters we have. All right, so this way we'll say, okay, create an indicator. This is quarters. Top one. I'm not going to touch yet. Let's say, okay, we're going to run this, and $1.50 gives you 6 quarters. However, that's not very well optimized, because if you say give someone back $1.50 in change of quarters, they'd be like, dude, I want dollar bills. So what we got to do is take this remainder, not yet, not remainder, take your quarters, copy their quotient remainder, quarters, divide this by 4. So now you have your dollars and your quarters. All right, so I run this. $1 and, well, 6 quarters. However, we don't want just $1 and 6 quarters, because that's $2.50. So I get rid of this quarters here, delete that. And on this here it says where the R is, right click, create an indicator, and this is now your quarters. All right, so if we run it, $1 and 2 quarters. I move my dollars down here so it's stackable. All right, so $1, 2 quarters. I pay $3. I get $2 and 2 quarters. 3, 4, as it should be. So if I make this 3.75, then I'll get 3/4 and $2. However, let's say this is actually 3.80. Right? So we still have $2 and 3/4, but we still have 5 cents that we still need to get back. So that's where this remainder up here is going to come into play. So we're going to copy this again. Take this guy when we divide it by quarters, drop it all the way down to here. Move my stuff around so it looks a little bit neater. And now for this one, we're going to divide this guy by, what's after quarters? Dimes. So 0.1. So create an indicator. Call it dimes. Code. No, don't be mean. All right, so now at 3.8, we get 0 dimes, and we still have 5 cents, right? That's the other. So we're getting $2, 3/4, and 0 dimes. We still have 5 cents. We got to get to nickels. So get rid of that other. All right, and we're going to copy this guy again, up and down, grab the R, and drop it over here to the input. Divide this constant by 0.05. That'll give you a number of your dimes. Okay, so you run it. I'll bring dimes over here first. I called dimes twice. This is nickels, my bad. So we're still lost 1 cent. We gotta get pennies now. Right? So this time, we just want to do a divide because we don't want anything smaller than a penny. Take your R, drop it in here, and divide it by 0.01.
Comparison.
Nope, numeric. Numeric divide. And create an indicator. Pennies. Run it. And we'll drag them over here first. Ta-da! $2, 3/4, 0 dimes, 1 nickel, and 1 penny. So it does do this not super optimized. So if I had, it'll give me 5 pennies instead of just 1 nickel. But I don't quite know why it does that. Something to do with the floating point precision. So close enough. Yes.
What are my so cost of items at the top wire branch?
Mm-hmm.
Is blue still. So the rest of it is orange.
Did you right click on it? Went on to representation.
Right. So the box itself is orange. The wires are blue.
All right, so we now have dollars, we have quarters, dimes, nickels, and pennies. Congratulations. However, what was that?
So where it says like your change, it's giving you negative values.
What do you mean?
So right here, $.
Okay, so an issue that Nick's trying to come up with here. So if I run this and my cost is more, you haven't paid enough, they're still saying, hey, I'm giving you change out for stuff, right? You don't want that because you don't want to get change back if you're not paying enough money. Right. So what we can do here is right-click on quarters and create a local variable. Here's this little thing here. All right, drop over here. Do the same for dollars. Create local variable. Dimes, create local variable. Nickels, create local variable. And pennies, create local variable. We're going to go over here to you haven't paid enough. And we're going to control click drag them in. Yeah. Goodbye. I'm going to finish it next. Okay. I'm going to show you here from the work in 10 minutes or so. All right, so however, these are all read values right now. So, bye, Marco.
Bye, Marco.
So go to numeric, double, or yeah, this one, the orange one. There's a wire 0 into all of this. No. Yep. All right, so wire it up so that you get zeros into your, you haven't paid enough. So this will get zeroed out. And then do the same thing under true. Make sure to control click and drag them in, because if not, then you're going to have issues where it tries to make extra stuff which you don't want. So control click drags them in. And then we can delete these guys over here, drop in another double at 0, and just wire him up to be 0. So this way you're not getting cash back if you don't pay enough. Right?
Hold on. Not like I'm sure.
Did you control click drag?
Yeah.
Are you control clicking dragging from the edge of it or from its actual? Yeah, make sure you're clicking on the edge of it. There you go.
Because in the center it brings the drops in.
Should we make a numeric?
Yep. Constant 0. Drop it in. Just wire it. Make sure it's 0. All right, so now that we have those other cases taken care of and they're writing zeros, so you're not getting any cash back when you shouldn't be, we have to turn all these into a string so that our cashier can tell you this is how much money you're getting. Right? Because you want them to tell you and not just hand you your stuff so you make sure that you're actually getting the right amount. So we're going to go ahead and go back to our string, format into string, and drop them in here. And we're going to put in our dollars first, right there to input 1. And then we're going to drag this guy again, just like we did with the original concatenate string. So 1, 2, 3, 4, 5. So you got 5 of these inputs, and wire up your quarters, wire in your dimes, wire in your nickels, and wire in your pennies. Make sense?
No. Wait, which one is that?
Right click, string, format into string. Yep.
Okay.
And then you can drag the bottom and make it more inputs for more values. And then you're going to, once you have all 5 of them plugged in, right click, edit the format string, and it'll auto-populate with %f, 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 %f. We want to add some stuff into here. So in between the % and the f, you're going to add 1 point between each of them. 1 point, 1 point, 1 point, 1 point. So you get at least one significant figure for each of them. because if you have more than 10 of one of them, it should be bumped up to the one above it, right? 1 point F. And then in between them, we're going to add descriptors. Say, so for this one, after the F, we're going to do dollars, comma. After this one, we're going to go dimes, comma. And we're going to go nickels, comma, quarters. Quarters, dimes, nickels, pennies. And it builds this lovely, lovely thing for us that's so massive and messes up our stuff. And then enjoy again, go to string, concatenate strings, and we're going to add this output string along with our input string. Do this part of the wire here. And wire him into the output. Now when I run, the cashier will say the change is $0, 3 quarters, 0 dimes, 0 nickels, and 5 pennies. Any questions from that?
Sorry.
Make sure you have all 5 of these plugged in with values.
Right.
Right-click, edit the format string.
Did that.
%1 point F dollars, comma, quarters, comma, dimes, blah, 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 blah. Concatenate string. Plug your changes, plus this one together, and wire it in the output. Under right-click, string, it's like the second one. And you wire them into the output. Now you can have this do, whatever. Say, cost of item is $60. You haven't paid enough yet, and you want to pay, say, 72.48. $12, a quarter, 2 dimes, 0 nickels, and 3 pennies. Any questions? Yes.
Where did you get the one that's connected to your
This guy? Right click, string, concatenate strings, like the second one right there in your string blocks.
So what was the block leading to that?
So this one, this is my format into string. And what I did was I pulled down the bottom so it had 5 inputs. That is 6. You only want 5 because you have dollars, quarters, dimes, nickels, and pennies. So that way you can get it all in one batch, and then you format it with one big long format string. So you don't have to have 5 of these blocks and 5 different formatters. It just makes it much easier if you have them all and you just throw them all together. So then if you go ahead and run, you can do whatever you want with this. It'll tell you what you're paying and what you're not paying enough of. If I pay $500, I get $380 back. Pretty sure someone would look at me funny if I paid them with a $500 bill, right? All right. Any questions?
Change. And now say a little bit about it.
All right, so I did promise you guys a quick game of Hangman. Michael gave it to me, and it should actually work this time. Save all my changes. All right, who wants to guess a letter?
A.
Nope, there goes his head.
E. S. U.
Oh.
I heard U, and I heard O.
C.
M.
Red.
Bum, 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 bum. Oh, it doesn't show what the word is. Okay, play again. Guess a letter.
Or is it the same word?
I have no idea.
Okay, so it's the same word.
O.
X. You saw that girl.
C.
Hold on, I heard three at once.
C. Wait, C, like I, C, R? No, you said R. It's chicken something. So A.
All right, so C, I, E,
B. There you go. H. K. N.
da 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 da.
L.
No, you won. It's chicken.
Oh.
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 Yeah.
Congratulations. You guys guessed the word. And three people in a head.
You can show us where to access Labview.
Yes, so Labview, what you do is you go to National Instruments. Spelled it wrong, but whatever. Right, and so what you can do is you make an account over here, right? Create a new user account, and it'll step you through the user, how to make your own user.